Yeah, we are following some kind of idea which was introduced to you by Dr. Techman. We try to substitute the diseased liver cells by healthy liver cells in order to give you the functions which do not function in an alpha-1 liver by healthy hepatocytes, which are the liver cells. The good thing is that each single hepatocyte can do all of these multiple functions the liver can do as a whole. So you really can substitute the diseased liver by healthy hepatocytes. This idea of hepatocyte transplantation is, let me say, about 35 years old, and it works quite well in a row of animal models. Nevertheless, the clinical breakthrough of this kind of therapy is still awaiting. We don't have, let me say, big numbers of patients being treated by hepatocyte transplantation. And the reason is we have no donors because we have too less donor livers to isolate the liver cells and then to transplant them into recipients. Therefore, we started another approach, and that was to generate hepatocytes from stem cells, to make liver cells out of adult stem cells in this case, which may be isolated from adipose tissue, from fat tissue, in very high numbers. And the method to produce these hepatocytes is rather easy. It's a very simple procedure, and you can then transplant these hepatocytes in a diseased liver by a very simple method again. And then you can see that the diseased liver is repopulated by the transplanted stem cells in this case. Coming again to the initial remark, we wanted to substitute diseased hepatocytes by healthy hepatocytes raised from stem cells. But actually we saw there is another benefit of using this kind of stem cells to an alpha-1 trypsin deficient liver, and that is to prevent the progress of fibrosis and cirrhosis and hepatocellular carcinoma. And this is a general feature of this kind of stem cells, that they might prevent the formation of scars, as it was introduced to you before. And as such, you prevent the progress of liver damage, of hepatocyte damage, and actually we saw that we had a decrease of these liver enzymes, as mentioned before again, and an increase of plasma protein synthesis. So we have some good indications that there could be a benefit in preserving the liver from damage in these patients. The problem may be that this is not a very sustained procedure, because the cells in these liver have a certain survival time, and after this time you get diseased livers or bad livers again. So you have at least to repeat this kind of therapy. But we are currently trying to find out the factors which are responsible for this multiple action in preventing, for example, fibrosis or shielding the liver for damage. And we have some good candidates which might be even better than to transplant the cells, to isolate these factors and then to provide the liver with the factors to protect it from damage.